We've been using this idea of radicals, and I want to talk about how it's connected to this idea of a rational exponent. But let me make sure radicals are totally clear. When we have a radical, the idea is that if I have a fourth root of 81, for example, I'm trying to find something that multiplies by itself this many times to make 81. If I have something like this, I'm trying to find something that multiplies by itself 3 times to give me 125, something that multiplies by itself 5 times to give me 32. And so with some poking around, you can figure out that 3 times 3 times 3 times 3 is 81, or that this might be 5, since 5 times 5 times 5 is going to be 125, and this would end up equaling 2, because 2 times 2 times 2 times 2 times 2 is going to give us 32. So there's this idea about exponents floating around here, but it's a bit of an opposite idea. Instead of multiplying the number by itself, we're trying to find the number that multiplies by itself. It's a little bit different. And so it kind of sounds like exponent-y in a way, and it leads us to this idea of a rational exponent. And a rational exponent means if we're going to have an exponent, but it's going to be a fractional exponent. And the idea of it being a fractional exponent, I just want to mention this, is that if you think about a number and you have it as a reciprocal, that's kind of like an opposite. Reciprocals of numbers are kind of opposites. And if you forget what reciprocals are, that means you take a number and you basically flip it over. Like, for example, 2/3, the reciprocal of 2/3 is 3/2. You flip the number over. These are kind of opposite. And to explain that, if that's not obvious to you, and there's no reason why it should be, if you had a problem like this down here, you definitely could take, most of you think, and you as rightly think, that you would divide both sides by 2 to get the answer. You divide by 2, the opposite of multiplication is division, life is good. But you also could, you could multiply by a half, and multiply by a half. You can use the reciprocal as an opposite as well, right? Because if I took half of both sides, I get the same answer. I get x equals to 5. So we don't usually think of reciprocals as opposites, but it's really helpful if you can start to kind of get that in your brain a little bit, because it makes this whole part make a lot more sense. Because what we're going to sometimes see, instead of the fourth root of 81, is we might see a 81 to the 1/4 power. Or you might see a 125 to the 1/3 power. And when you see something like this, you just have to recognize that what you're being asked here is the same thing you're being asked here, which is, don't take 125 and multiply it by itself a third of a time. That doesn't make any sense. But do look for a number that if you multiply it by itself this many times, 3 times, you'd land on 125. If you see something like 81 to the 1/4, I'm not taking 81 times itself a fourth of a time. I'm looking for something that multiplies by itself 4 times to hit 81. So this guy, this is how this would look in radical notation. If I were to use rational exponents, it'd be looking like 32 to the 1/5 power. And if I were just to see this somewhere, I would know, find something that multiplies by itself 5 times to give you 32. So it's the same concept written 2 different ways. Rational exponents or radical notation. They both exist. You have to be comfortable with both of them. Good luck.